And for exercise 10b, looking at the weather associated with the track of low pressure systems, ties in with some of the things we've been discussing in class already. Here what they're asking you to do is take a look at two hypothetical low tracks and compare the weather that you might get in Detroit as a result of each low tracking. So taking this diagram and superimposing the hypothetical positions of the warm front and cold front associated with the track of each low pressure system gives you an idea of the difference in weather that Detroit would experience depending on whether it took track A or track B. So first of all, following track A frontal positions, we can see that Detroit does not experience the passage of any fronts. Center of the low pressure stays to the south and east of Detroit, and so does the associated frontal boundaries. And so you might expect to see a wind shift initially from the east, and as that low approaches, that counterclockwise circulation, it's going to actually veer up towards the northeast as the low approaches, and therefore we stay on the cold side of that system, or in that northwest sector that we looked at in exercise 10a. By comparison, if we take a look at track B, we can clearly see with the center of the low passing to the west and north of Detroit that we do experience the passages of fronts. And applying the hand twist model here, as that warm front passes, we might go from a easterly flow ahead of that warm front to more of a southeasterly flow in that narrow wedge of the warm sector between the warm front and the cold front. And so we do briefly get into the warm side of that system with the low passing north and west of us. So if you look at the two different tracks, you can see that the potential for snowfall at Detroit would be best exhibited by track A, where we stay on the cold side of that, whereas two periods of precipitation, rain, then fair weather might occur if the cyclone takes track B. So getting into that warm sector, we might see a period of rain as the warm front approaches, perhaps another period of precipitation following that as the cold front moves through. Regardless of the track, as the low is approaching Detroit, air pressure is going to decrease, and as the system moves away from Detroit, air pressure would tend to increase. And more likely than not, the next system going into affect Detroit is going to be an anticyclone or high pressure system. Then the application section, I take a look at, again, real world examples with two areas of low pressure, one moving across the Gulf of Mexico associated with a quasi-stationary frontal boundary extending here along the northern portion of the Gulf, and another low pressure out here along the Nebraska-South Dakota border. Looking at some of the present weather conditions as we take a look at this map, looking at the current weather over Dallas. But you really can't even make out the current weather symbol, and so they show it to you in the question with the triangle with a dot in the middle. And if you go to your extras section in the surface station model, you'll see that that actually represents ice pellets or sleet occurring with a surface temperature of 33 and a dew point of 31. And this type of precipitation is consistent with what you'd expect from a winter storm in the southern United States. They also show the resulting snow precipitation that occurred with this system as it tracked along the Gulf of Mexico. And as you might expect, the area or band of heaviest snow is consistent with that northwest sector of that low, or that cold sector, as the low tracked to the east-northeast.